In this video, I'd like to talk about the math question of the day for February 8th, 2023. And for this problem, we need to rationalize the denominator, and we will assume that both x and y are positive. So to answer a question like this, you need to have a solid understanding of Algebra 1 and Algebra 2, especially dealing with the radical notation and how to rationalize these fractions containing radicals. So at this point, go ahead and pause the video, see if you can work this out on your own, and when you're ready, go ahead and unpause the video and we can go through this together. Now at this point, I will assume that you have at least attempted the problem, and we can start going through this together. Though, as always, if you do have a suggestion for a future video, feel free to leave it as a comment down below. Now, when rationalizing a denominator, let's look at a simpler example. Let's say we have 3 over the square root of 2. To rationalize this, essentially we want to get the radical out of the denominator. So to do that, what we can do is multiply the top and the bottom by the square root of 2. Since when we multiply two square roots together, as long as it's the same number underneath, they will cancel and you just get the whole number. But let me write that more explicitly. We would have 3 root 2 over root 2 times root 2, which is the same as the square root of 2 squared. And square root and square cancel so that we get 3 root 2 over 2. But this entire process of taking this fraction here with a radical in the denominator and rationalizing it, you can see just takes that radical, this square root, out of the denominator, and now it's in the numerator. However, when you have an expression like this, it's a little bit more complicated. So let's look at a second example, though you can say this was our first one. The second example, we can look at one that's a bit more complicated, where let's say we have 3 over 2 plus the square root of x. To rationalize this denominator, we need to multiply top and bottom by what we refer to as the conjugate of this radical expression. And the conjugate is fairly straightforward. Let's say we have root a plus root b, then we would say the conjugate would just be root a minus root b. And the advantage of the conjugate is that if we take our original expression and we multiply it by the conjugate, we will end up with a difference of 2 squares, which you might remember from algebra. But basically, when we multiply this out, when we carry out this distribution here, the middle terms will cancel out. We get root a times root a, which is just a, square root and square cancel. Then we get minus root a times by root b, plus root a times by root b. So those middle terms cancel. And then we get minus the square root of b times by the square root of b, which, again, the square roots will cancel, and we just get minus b there. So by multiplying by the conjugate, notice that our product has only whole number values. So it no longer has these radical signs. So when we take this expression and we multiply the top and bottom by the conjugate, you just flip that middle sign. So we multiply top and bottom by 2 minus root x. Notice that this expression here would simplify to 1 since we have something divided by itself. So we're not actually changing the value of this. We're just rewriting it so that we don't have radicals in the denominator. So actually carrying this out, we would just distribute. You get 6 minus 3 root x. But in the denominator, you get that difference of squares. You square the first ones, and then you subtract the second one squared, since those middle terms will always cancel out when you carry out distribution. So you just get 4 minus root x multiplied by itself. So rewriting everything, we get 6 minus 3 root x over 4 minus x squared. And this no longer has a radical in the denominator, so it's been rationalized. And now that we know the strategy, that we essentially just need to multiply top and bottom by the conjugate, we can now apply it to this specific problem. Let me just make the right around room here. And I'll start by rewriting it. We have 4 over root x plus 2 root y. And the conjugate of this, we will rewrite the first term. but now we will subtract the second term, and we'll multiply the numerator and the denominator by the conjugate of this original denominator. And when we distribute the 4 to each of these, we get 4 root x minus 8 root y. And in the denominator, we will have to use FOIL or distribution. The root x goes to both. The 2 root y goes to both. Root x times by root x, that's positive x. Root x times by minus 2 root y. Let me just write all this out. We have minus 2 root x, root y, and then we will be adding that same expression to root x, root y. And then we have 2 root y times by minus 2 root y. We would get a minus 4. And root y times by root y is just y. So these middle terms, notice, cancel out. So this expression just becomes 4 root x minus 8 root y over x minus 4y. And what you can see is that we were able to rationalize this. We no longer have the radicals in the denominator. They are now in the numerator.